Hello everyone, welcome to the course on electronic system for cancer diagnosis. This is a continuation to the previous module where we've gone through the different essential or the must need equipments required in a biomedical research facility where you study and understand the change in tissue biomechanics, the underlying structural features, the stiffness, elasticity property, and how the electrical, thermal and mechanical properties of these tissues can be leveraged using the biosensors what we intend to fabricate. So, coming to the next set of equipments, what would be essential during the process of fabrication or even during the analysis where the cell and tissue cultures which are cultured and then extracted and then analyzed, and during the entire process there are several equipments which we would be utilizing. So, let us get a hands on these equipments and understand how these can be used and what is the purpose of these. So, coming today, I am sure you all studied, understood about lithography process, the soft lithography process, which is a very important step during microfabrication. I am sure Professor Hardik has covered the detailed procedure of the fabrication of various sensors, what had been fabricated by him, what is the steps, what is the process flow of the entire fabrication. So, when we are talking about one important step is lithography, that is how you get these features onto the resist or onto your the device. So, how do you get develop these features, and that is where soft lithography comes into place. So, when we are talking about soft lithography, I am sure that you've heard about the pre-bake and post-bake during your lecture classes. So, what is this pre-bake and post-bake, and why do you have to carry them in a specific time interval, or there is a procedure which has to be followed. So, there is a most important or widely known photoresist, the SU8 photoresist, which is a negative photoresist. When I say negative, say what happens, there is a difference between the photoresist, that is positive and negative. There are two variants, and what happens when you say negative photoresist, that is the exposed, you create a mask in such a way that the photoresist which is exposed to UV light, the cross-link enhances and then it becomes more solid. The chemical bonding between the structures which are exposed to UV becomes strong, and then the remaining part which gets the part which remains unexposed can be dissolved easily while you are putting them in a developer solution, and the other way around is your positive photoresist. So, when we are talking about SU8, which is an epoxy based negative photoresist, I am sure this is the most widely used photoresist to develop features or to create molds while you want to fabricate your devices. So, when you have the SU8 photoresist, you have to, how do you develop these features? So, there is a process flow. Let me show you this figure. So, let us say this is your disc, for let us consider this is your wafer, it could be the glass wafer, silicon wafer, and what happens is you dispense the photoresist. The amount of resist dispensed onto your wafer, the distance between the two has to be maintained minimal, because you do not want any air to come and contaminate your sample. So, there should not be any kind of air bubble formation. So, this here is the chuck which is holding your wafer. When we say, there is a vacuum chuck here and the spindle which rotates, it is controlled by motor, and this rotates and this holds your wafer tightly here, and then the dispenser flows your photoresist. So, what is the photoresist we are talking about here is the SU8 photoresist. So, assume, and then once it has been dispensed for the required amount, the spinning happens, and then there is a uniform spread, and then there is a formation of a thin film of photoresist across your wafer. And now after this step, once there is a uniform deposition of this SU8 onto the wafer, you have to bake it. So this process is called post baking. Why do you have to do post baking? In order to remove any amount of dissolved solvents in the SU8 photoresist, you bake it for the desired temperature. It could be like 80 degrees or depending on the type of photoresist what you use. You set it to a certain temperature, and it could take a minute or two just on the hot plate, and then you remove the dissolved solvents, and this is an essential step. I will show you why this becomes an essential step. You have to remove the dissolved solvents in this step, and then the resist, which is more liquid in nature, when you heat it solidifies, not too hard, but it is now semi solid, so that you get the required features developed on this photoresist. Now that we have seen this, if you could see this here, say this is your wafer and then the photoresist, and the solvent is driven off. This becomes an essential step. You do not want any solvents while even before you develop features. Ensure that this process is followed. There is a point here. Now this entire thing, the reference is here. Kindly, in case you require further information, you could always look into these, and this is a reference from where I have taken the material. And the important point here is the microwave heating are also used in production line. However, baking on hot plate is usually faster, more controllable, and does not trap solvents like convection oven on baking. So this point needs to be taken care. Now, in the clean room facility, we have seen when we are talking about baking, you could even think of using an oven. Right behind me here is the hot plate. The composition of the plate here could be ceramic, the one which you can see here, or it could even be aluminium. This is a magnetic stirrer along with a hot plate. You could set the desired temperature and time for which heating is required. So these are the options here. So let me turn it on. So as you can see the display here, you could set the desired temperature for the required time using the hot plate. Now, along with the hot plate is the oven, which we had used it in one of the modules for PDMS molding, and you had used it to bake the PDMS. Once the PDMS and the cross-linking agent were mixed in 10:1 ratio, and the features and then once it was poured onto the mold, you put it onto this at 70 degrees Celsius for 2 hours. So that is when you have used an oven. If you remember previously in one of the modules where we had used this. So there are two things when we are talking, that is one kind of baking. So PDMS baking, so there are two things. We have the hot plate and we have the oven. So what do you want to choose when you want to bake? Like if you would see, I have used this for the PDMS stuff. That is fine, but when you are talking about SU8, the photoresist, and when like I mentioned, post baking requires usage of hot plate and not the oven. Also there are several advantages. The oven has several compartments, different slots, it can accommodate multiple wafers, it can accommodate many things. But when you see the small hot plate, it can accommodate just a single wafer. However, it is always important that you choose and prefer using the hot plate when you are doing the post baking. I will also explain what is the pre-baking and the post-baking. So, always choose the hot plate over the oven. Why? When you are using an oven, the heat what is generated inside the oven goes from the surrounding environment into your, it flows through the resist and flows through the center, it flows from the top to down. So, that is not what you want. This does not ensure removal of solvents, the dissolved solvents which are there in the photoresist which has been uniformly coated on the wafer. However, when you prefer using the hot plate, what happens is it is more like the convection heating, the conventional the stove based cookers or any other utensils. You have the heat generated at the bottom and then they are in contact. In the same way, the hot plate is in contact with your device. So, what happens when the heat is generated from below? Any solvents are taken away. So, the heat generated from the bottom is taken up. So, it forces the solvents to move away from the surface. So, this ensures complete removal of solvent from your photoresist. I hope you have understood the importance of using hot plate over a microwave oven. So, what happens if you do not use say the desired time, you set the desired time, you overheat them, but there are chances of features, there could be cracks which could be formed on the photoresist what has been developed. Like, let me show you an example. This here so here if you could see these tiny cracks which are formed and there are even air bubbles, improper. So this is your feature and then there are cracks across the SU8 photoresist. This is not what we want. These features could hamper your device functionality. Assume your device is here and then there are cracks which could be formed. So, you could not use your device anymore and it hampers the entire functionality, and this is an undesired feature which has to be avoided and taken care while you do the baking process. So, this is again taken from a reference here in case you want to study more about the process flow and what has caused these. So, now you know the importance of uniform heating. Uniform heating is guaranteed when you use a hot plate, and always prefer using a hot plate when you want to do the baking process instead of using the oven which could be there in your, which could be used, but otherwise more efficient is your hot plate. Now, coming to the pre-baking and post-baking process. Why do you need to pre-bake? Pre-bake in order to remove the dissolved solvents and ensure good cross-linking of the desired features. And then when does the post-baking come? Once the SU8 has, the photoresist has been dispensed onto your wafer and it is spin coated uniformly onto your wafer, and then you put it on your hot plate for a desired temperature for a minute or two, and this pre-baking is an essential step, and once this is done, only this ensures removal of solvents and thoroughly cross linking and ensures cross linking in future. So, once this is done, then you expose it to UV while your mask is in between. It could be contact or non-contact based depending on the process you follow, and then expose UV. And once the features are formed, you have to, and immediately after the UV exposure, again put it on the hot plate, and this is the post exposure process. Why is this step carried out and why is it important is, even before you put them into the developer solution, once you, after exposure, you put the wafer onto your hot plate, and this ensures that the part with the features which has to be developed, when you heat it, the chemical composition changes such that there is a highly efficient cross link which is formed between the features which are to be formed, and the ones which are not exposed would be easily soluble in the developer solution. In order to ensure this process happens, you have to bake it after the UV exposure and then set the desired temperature time. And once you bake it, take it out, put it onto your developer solution, and then after developing, you would see the right features onto your wafer, which is the desired features. So this becomes an important step. Now hope you understood the importance of using the microwave oven when it comes to molding, PDMS molding, and the importance of using a hot plate when you want to pre-bake and post-bake. So this was what was intended to be taught in this module. Now let us see the other device, which is another essential component while we are working with some biology, cell and tissue modules. The next equipment what we would be talking about is the microcentrifuge. Like the term said, micro, it's a small compatible benchtop module which we would get our hands on very quickly. Centrifuge, when I say, it's more like a device which rotates, and then the working principle is more like the centripetal force. Like say I spin a ball around my hand when there is a string attached to it. What happens is, as it revolves, it is always directed towards the center, where I am holding the force. So that is your centripetal force. So on a same working principle is the centrifuge. What happens is, as it rotates, the samples what we keep would rotate, and then the different constituents in the sample would have different mass and density. So the amount of force that is acting on each of this is different, and what happens while it revolves is the tendency of the denser objects to settle down across, the radial force would be higher when compared to the lighter ones. So this phenomenon is what is used in order to separate different particles of different densities when you have a solvent or a solution mixture which has to be separated out. So let's see why the microcentrifugation is required for us, and let's see the different features a microcentrifuge device can offer.
Okay, you can start.
So this is the microfuge what I was talking about, and like I said, centrifugation is applying the centrifugal force in order to separate different particles from a solution based on their size, shape, density, viscosity and other features. Now what happens here is, if we want to study the entire, let's see the different features the centrifuge offers. As you can see, this is a small compact benchtop configuration of the centrifuge. Now there are some factors which you have to consider while you choose a centrifuge. Even before we see what are the factors you have to consider, let's see what are the features the centrifuge offers. Here is the speed setting. like I mentioned, it would rotate. Spinning action of the different sample tubes which would be placed inside happens. So in order to adjust the speed, the knob here, and then the time for which the desired time for which the spinning has to happen. So let's open the centrifuge, and now there is a warning that is written here. Moving parts may cause injury. Do not open the lid until rotor stop. Always ensure you follow this protocol, because what you spin could be hazardous material. It could be any kind of biohazard which you do not want to inhale, or it might explode to the surface around and contaminate the entire device here. So ensure that you stop, wait for the device to stop, and then open the lid. Now you can see, so this is the rotatable, this is supported on the rotor, and on this are these tiny 2 ml. Here it says 1.5 ml. So there are different sample tubes what this can support. So it supports up to 2 ml and 1.5 ml. So the very small amount of samples which are taken in these sample tubes. So here is the 1.5 ml tube. You could also use a 2 ml. So anything less than 2 ml is what the device can support. So these sample tubes will hold the sample. It could be any kind of cell, tissue culture in which centrifugation is required, or when centrifugation is done to separate out different particles. Now how many slots does this support? So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 slots are supported. So you could use 8 into 1.5 ml tubes, and there is a lid for each of this tube. And why is this precaution taken? Because you could see that the spinning rate is very high. So let's switch it on and see the operating speeds. So it's the amount of set speed multiplied by 100 rpm. So when they are rotating at a very high speed, you do not want your samples to be spluttered out. Hence there is a lid that is provided on each of this as a safety measure. And now that this supports, there are variations in the microcentrifuge. There could be multiple options. Here, like I said, it supports a few sample holders, and there could be multiple options. It could even support much more numbers. It all depends on how much of testing is required, the amount of time that is required, and the study purpose. How long would it last? So if the process takes a day, what is the amount of sample which has to be tested? Based on all these parameters, you could choose the centrifuge you want and the amount of slots it could support. Now that we've seen the different casing, this is one sort of a revolving structure with these things, but otherwise there are other centrifuge which could even support different rotating structure. It could be a plate-like structure where you want to have your culture or any kind of centrifugation which is required. That could also be attached to this for centrifugation. In this case, you can see the kind of structures what we are using. Now let's turn it on. You could see how robust the casing is. Like I already mentioned, it is very essential when you are dealing with hazardous cultures like bacterial culture, virus, HIV, or any other cultures which could cause contamination in case there is a break or a leakage or a damage that could be caused either to the solvent tube, the small sample tubes what you had seen, the damage could either be caused to that or the damage could be caused to the lid, and we would be exposed to the biohazard. In order to ensure all of this, we have a robust casing like this. And there are different casing, like you can see here, this is a plastic casing. There are others centrifuge which have a metal casing. However, they have their own advantage and disadvantage. When it comes to these, they are more transparent and you could directly visualize in case there is a leakage, and accordingly take precautions even before you stop or open the lid. And when it comes to metal, it is more robust. However, they are opaque and hence you cannot see the samples in case there is a leakage, what happens inside. Yeah, like the metal casings, they are very strong and more robust. However, in order to prevent them from corrosion, you could prefer the plastic casing. And another option is when you need a more robust structure, you could go with the metal casing. And in case it corrodes, you always have the other things like the autoclave, or you could even use the ultrasonic bath. Like I mentioned earlier, how it can be used to remove the corrosion from metals. So you could clean them and then reuse in case you require metal casing for centrifugation. So now let's assume I have a culture medium inside each of the sample tubes, and then I want to do the centrifugation for the desired time. Now let me turn it on. So now we've understood that we follow the instructions what are provided. You close the lid and then now we set the RPM. Now that the LED is showing RPM, let's set the RPM to 10. 10 implies 10 into 100. So we are setting it at 1000 RPM. Now let's set the time for a minute. Now you can see how the rotor, which is holding the 3 sample tubes what I had placed, is rotating at 1000 RPM, and this would continue for a minute. So it always depends on the amount of throughput what you need. Now as I mentioned, it has this 1.5 or 2 ml tubes, and it could spin some amount of sample. So based on your requirement and based on the amount of throughput, you could choose the different centrifuge which could accommodate more number of slots. So this is one kind of adapter. So there are manufacturers which can provide you with different adapters, so you can switch between the two so that you accommodate different size tube. This is a small size tube. You could, in case required, you could use the different size tube or different type. Like I said, the plate model can be used with the help of an adapter which can be fixed. So this was the centrifuge. Always ensure you follow the safety while you spin, because there could be hazardous materials. Like in case of medical laboratories, they may need to process blood during the microcentrifugation, and these samples are unsettling. In order to safely work with them, because occasionally, like I already mentioned, the sample tubes can break. Now that we have stopped it, we can open the lid. These sample tubes what I mentioned could break at the bottom and could splash or spread on the surface, which could cause contamination. And sometimes it is also required to have some radioactive labels across them. There could be biohazard, bacteria, HIV, any other kind of virus. Hence, you should always choose a rotor lid that fits well enough to ensure proper protection is certified when you are using biohazard materials. Now that we've seen how the microcentrifuge can be used for centrifugation process, what are the different features you have to choose and opt among the different things, try the different adapters in case you want to do the centrifugation with sample tubes of varying size. You could choose them based on the amount of throughput you need. All of that can be considered, the type of casing, like I mentioned, the advantages of using plastic or using a metal casing. Considering all of this, you come to an optimal solution of what is the kind of centrifuge can be used for your purpose. So in this case, we have the tabletop centrifuge. I have shown you how the working principle and why centrifugation is required in case you want to separate different culture from different particles from a medium. You use the microcentrifuge. I hope this has thrown enough light on the purpose, the choice and how to use a microcentrifuge. Thank you.